Hello, I am John, and I am a transport researcher. Every day, millions of people are taking public transport such as trains and buses. My job is to plan on the transportation routes to ensure a smooth journey for everyone. Now we will move on to the mathematical concept, which is sequence and series. Sequence is simply a list of numbers written in a definite order. A simple example will be 1, 2, 3. Next will be series. Series is the summation of the sequence. An example will be 1 plus 2 plus 3 plus 4. Let's take NTU's shuttle bus as an example. The shuttle bus will start from Pioneer MRT, then it will proceed to Hall 1 and 2, Canteen 2, Student Health Center and TCT Lecture Hall, before heading back to Pioneer MRT. This is a sequential process. Series will be the total distance the bus traveled from the start to the end.
Now let's look at how sequence and series plays a part in Singapore MRT train.
Let's look at the red line, which is also known as North-South Line.
As you can see, the red line has 2 points: Marina South Pier Bay and Jurong East. In between these 2 points there are several stations. Let's assume a train is departing from Jurong East Station, which is also the starting point. Series is the summation of the distance it covers from the start to the end point, which is accumulated by adding the previous distance to the current distance. For example, in order to find the distance traveled from Jurong East to Orchard, I just have to sum up the distance of every interval. Now let's look at how a sequence works. As you can see, the station moves from one station to another in a sequence. Can the MRT move backwards in the middle of the station? The correct answer is no. In a sequence, the MRT is not able to move backwards. It has to move forward until it reaches the endpoint. In this case it is the Jurong East.
Now, we are going to introduce a method called calculus of real-time distribution, mobility, and interaction, which is also known as CARDME. I will explain in detail exactly what CARDME is. In definition, CARDME is used to specify and verify spatial and temporal behaviors of transportation system. So, what do they specify? CARDME specifies stations and stops using nodes. They also specify spatial and temporal constraints using boundaries. Movement of trains are indicated by lines that connect the nodes, in a sequential order. Next, what do they verify? CARDME needs to make sure that both trains do not occupy the same spot of the tracks at the same time. Therefore, they utilize 2 golden principles: deduction rules and equivalence relations. In deduction rules, if a train currently occupies track 1 at 6:30 p.m., it will make sure no other trains occupy that same track at that same time. On the other hand, in equivalence relations, it provides a list of trains that utilizes each track.
Let's take a look at another method called calculus for communicating systems. For example, a train traveling from Jurong East to Choa Chu Kang is represented by. Now, looking at CARDME, we can see that CARDME have a temporal constraint. This is very important when using CARDME in transportation system.
So, how can we use CARDME to plan the transportation system and routes for Singapore MRTs? Let's take Jurong East MRT station for instance. As we all know, Jurong East station has multiple train tracks that merge into one track. Therefore, we must ensure that 2 trains do not move off into the merging track at the same time. By utilizing CARDME, we first need to have to view the map like how CARDME would. Next, using CARDME's notations.
The first notation shows the train waiting for 4 minutes before leaving Jurong East Station. The second notation represents the movement from Jurong East to Clementi, which take 2 minutes after the train left Jurong East. Look at the movement of another train along the same track. The train move off 5 minutes after waiting. Both train will meet at Clementi. A second train took only 1 minute. This is not allowed as Clementi only has 1 track. CARDME help us to identify this constraint.
To summarize, series are used to calculate the distance of each stops, while sequences ensure that transports, like trains, move from one stop to another stop. Sequence and series in CARDME also make sure that there is no collision between the trains, and ensure that anyone who uses the transport system has a safe and pleasant experience.